My name is Sophia Yang, and I'm an upcoming PhD student at the University of Illinois at Urbana-Champaign. The paper I will be presenting today is titled Analyzing Patterns in Student SQL Solutions via Levenstein Edit Distance. I would like to acknowledge and thank my advisors for their help and support with this work, Professor Herman and Professor Alawini. I would also like to thank the National Science Foundation grant for supporting this work. To examine how students learn SQL, database instructors often manually analyze student submissions to a given SQL problem. Our research questions are first, how do students learn SQL? And secondly, how can we empower instructors to teach SQL effectively and with adaptability to tailor to different students? We collect our data from the Database Systems course, which uses an autograder for SQL assignments, giving us the opportunity to trace students' attempts at solving SQL problems. Our data comes from over 4 semesters, with each semester enrollment being approximately 400 students. Mitrovic created the SQL Tutor, which is essentially a learning support platform that slowly reveals a correct solution to students. Ahadi and his co-authors measured the difficulty of types of SQL queries by analyzing the rate of correctness students answer them. We have preprocessed SQL queries to remove insignificant parts in the preprocessing module, such as comments and redundant punctuation, including new line characters and white spaces. The results are then stored in a tree-like structure based on the structure of the query. The SQL keywords and attribute names are separated into 2 groups and then iteratively compared to sum the total Levenstein edit distance. The Levenstein edit distance is computed by detecting the smallest changes between the 2 strings being compared, which includes deletions, insertions, and substitutions or replacements. The final edit distance represents the smallest number of changes required to change the first string into the second string, with each change holding a weight of 1. For example, in the figure on our right, to change Levenstein into its scrambled form at the top, LNVETEHSIEN, we must replace 4 letters and insert and delete a letter, which sums up to 6 edits. We found that students generally take 2 different approaches at tackling a SQL problem, trial and error and divide and conquer, or a combination of the 2. In the middle, we present an example of a visualization created by our submissions visualizer, which depicts the Levenstein edit distance between the current submission number with the final submission. An example of a trial and error pattern is seen with submissions 15 through 17. The student's 15th submission is the one shown in orange, which has a semantic error, meaning the query was able to compile successfully but did not retrieve the correct results. In its next submission, it appends the where clause shown in blue at the end of its previous query. The query continues to have semantic issues, so the student replaces the where clause shown in blue with the one shown in red and submits it as its 17th submission. For divide and conquer, we see that the student creates and tests its subqueries first before merging them into its final query. The 47th submission shown in yellow served as the subquery of the 49th submission in purple, and the 49th submission served as the subquery of the 58th submission in peach. Lastly, we notice when edit distance doesn't change, it signifies that the student had either cleaned up comments in its query or resubmitted the same query out of frustration, like we see between submissions 25 to 28. We plan to extend our current work by providing an aggregate view format of the class to provide instructors quicker insights. We envision this to be implemented using hierarchical clustering, with the output visualization being a dendrogram, which can also be useful as a plagiarism detection aid. Furthermore, we plan to equip instructors with deeper insights on whether the student utilized multiple approaches and how they came up with their final solution by implementing global sequence alignment algorithms and the backtracing technique to create insightful visualizations. Thank you all for watching.